Hello, good morning, sir. My name is Yashwant. I am from CSC department. Today I am discussing topic apply a log-based protocol such as two-phase logging 2PL to a scenario where two transitions. Overview of the transitions. Transitions are sequence of operations performed as a single logical unit. Each transition must adhere to the ACID properties, atomicity, consistency, isolation, durability. In our scenario, we will analyze two transitions T1 and T2 interacting with shared data. Introduction to two-phase logging. Two-phase logging is a concurrency control protocol used in databases. It ensures that transitions are executed in a way that maintains database consistency. 2PL operates in two distinct phases, the growing phase and the shrinking phase. Examples: T1 starts and enters the growing phase. T1 acquires a lock on X. T1 reads X. T1 acquires a lock on Y. Scenario setup. Assume we have two transition T1 and T2 that accesses the same data items. Transition T1 will read and write to data item A while T2 will read and write data item B. This scenario will illustrate how T2PL can manage their interactions and prevent conflicts. Example for transitions. Transition T1. Operation 1. Read balance of account A. Operation 2. Write a new balance to account A after transfer. Second, transition T2. Operation 1. Read account information of account B. Operation 2. Write update information to account B. In transition T1 operations are: transition T1 begins by requesting a lock on data item A. After acquiring the lock, T1 performs a read operation followed by a write operation on A. T1 then releases its locks on A after completing its operations. Example and operations. Lock T1 locks data item A. Read reads balance account A for suppose $300. Right. Updates account A balance to $200 after deducting $100 means 100 is uh, um, cutted. Unlock releases lock on data item A and transition T2 operations. Transition T2 also requests a lock, this time on data item B. After obtaining the lock, T2 conducts a read operation and then a write operation on B. T2 releases the lock on B after finishing its execution. Example: lock T2 locks data item B, reads the current address of account B 123 maintains, write updates account B's address to 456 ELM ST, unlock releases lock on data item B. The growing phase. Both transitions start in the growing phase by acquiring locks on their respective data items. In this phase, they may continue to acquire additional locks as needed. However, no locks can be released during this phase until the transition reaches its end. Example: lock cell. Transition T1 holds lock on data item A and data item C. Transition T2 holds lock on data item B and data item D. The shrinking phase. Once T1 has completed its operation, it enters the shrinking phase by releasing its item lock A. T2, upon completing its operations, also enters its shrinking phase by releasing its lock on B. During the shrinking phase, no new locks can be acquired by the transition. And lock compatibility. Lock compatibility is crucial for maintaining transition isolation in 2PL. Shared locks allow multiple transitions to read a data item, while exclusive locks preventing other transitions from accessing it. This mechanism ensures that transitions do not interfere with each operations. Deadlock considerations. Deadlocks can occur when two transitions hold locks that the other needs to proceed. In our scenario, if T1 locks on A and T2 on B, neither can complete if they require the other lock. Deadlock detection and resolution mechanisms are essential to handle such situations in TPL. Deadlock cycles or transition waiting for locks to be released by each other. Two ways of dealing with deadlocks: deadlock prevention and the deadlock detections. And the conclusion and benefits of 2PL. Here we can see 2PL locking. If T wants to read an object, first obtains an S lock. If T wants to modify an object, first obtains X lock. If T releases any lock, it acquires no new locks. Look, locks are automatically obtained by DBMS, guarantees serializability. Here we can see two-phase logging effectively manages concurrence and ensures data integrity. By providing a structured logging mechanism, it prevents conflicts and maintains isolation between transitions. Implementing 2PL contributes to the overall reliability and performance of database systems. Thank you, sir.